All right, good morning, everybody. Thanks for joining this morning. Today's topic is Introduction to the NXF4000. So let's get started. So first, let's have a little meeting business. If everybody could please keep their connections muted or their phones muted during the presentation, that'll help a lot. And if you do have any questions during the meeting, please type them in the chat, and I'll see them there, and I'll try to bring it into the discussion. So with traditional burner control, the most basic form was on-off control. When automatic burner controls became available, that was the best available control technology. And over time, modulation did become possible with the advent of the proportional slide wire control and the modulating motor. And that type of control, which can still be seen today, is known as single point or linkage control. And it's called that because only one motor can safely be controlled by the slide wire. With linkage burner control, the linkage will link the air damper and the fuel valves together through a common linkage, and because of that, they maintain a fixed relationship through the firing range. Linkage burners can only be set up accurately on either low fire and high fire, and any firing rate in between is going to be subject to the position of the linkage and may not be optimal. During commissioning, all the intermediate firing rates must be checked for safe combustion but can't be individually adjusted. Another issue with linkage is that the hysteresis occurs from the tolerance or the slot present in the linkage mechanism, meaning that traveling up or down in the firing rate, you may not be in the same exact position. And this can vary while modulating up and down due to where the tension is present on the linkage at any given time. For the technology of the time, slide wire control was revolutionary. It's a mechanical system that creates a proportional output of 0 to 135 ohms based upon the set point and the actual value. This resistance output is then connected to a modulating motor. The set point and the proportional gain are set using springs. These are presented to the user on a printed legend, as you can see in the image, and as such, the slide wire control can't too precisely set the actual set point or differential because the exact amount is not actually known. Additionally, with only proportional control, it can be hard to reach the set point at times as there is no way to account for changing load conditions. The typical 0 to 135 ohm modulating motor that is used can be directly connected to the slide wire controls. The motors can be directed to the high and low positions as needed through the flame safeguard to purge and for ignition, and they are connected to the slide wire control through a relay when automatic run status is reached, and that's when modulation will occur. These motors run open loop, which means there's no feedback. The flame safeguard doesn't know where they are, and they do not have fine resolution. This means that while a motor may have a span of 90 angular degrees, this may only result in 20 or fewer different steps of modulation. And this is due to the inherent design of both the motor and the slide wire control itself. Parallel positioning burners allow the air and the fuel to each be individually controlled by a servo at each designated firing rate. Additional servos can be added for FGR, flue gas recirculation, or a sliding head position can also be incorporated. And this allows for a true characterized combustion curve through the entire firing rate. Instead of using wrenches to adjust the linkage, commissioning is done with an operator interface. The servos used are closed loop, meaning there's feedback, with much more precision than the typical modulating motor, with 900 steps of resolution over 90 angular degrees. This also eliminates all the hysteresis or the slop during firing rate changes. Slide wire control is also replaced by intelligent PID control. The slide wire's lack of resolution is directly addressed by that PID control. As technology has evolved, the shortcomings of linkage burners and slide wire control has been amplified by the changing efficiency and emissions initiatives. Although linkage may still be the lower cost option initially, over the life of the burner, these inefficiencies will result in a linkage burner probably costing more to operate and maintain than if it were parallel positioning to start with. So what is the NXF4000? The NXF4000 is a parallel positioning system, as we just described, with an integrated flame safeguard. This is the only controller that you're going to need to both monitor the flame as well as control the channels of combustion. So this is directly from the NXF4000 bulletin or the operating manual, and you would select the model you need based upon which agency approvals are required for the jurisdiction you have. There are two primary models, and that's the NXF4000 and the NXF4000 230-volt model. And this chart here shows the approvals for both the main controls as well as the accessories. And this is over 2 pages here. The NXF4000 occupies a small footprint in the combustion enclosure. The unit measures approximately 8 inches by 5 inches on the back panel and it has a height of 4 inches. Electrical connections to the NXF4000 are made to removable terminal blocks. Add-on cards are fitted within the footprint onto the main circuit board, so no additional space is required. The NXF4000 has an operating temperature range of 0 to 60 degrees Celsius or 32 to 140 Fahrenheit. It has an integrated cooling fan that is a replaceable part, so long life can be ensured in high heat environments. The fan is internally controlled by the NXF4000's temperature. If the fan were to run constantly, the design life is over 3 years, but again, it can be replaced, so you don't have to replace the entire control. There are two models of NXF4000 available, as I mentioned, a 120-volt model and a 230-volt input power model. Agency approvals vary for each based upon the needs for the market that those are directed towards. All accessories are compatible with all controls of either voltage. The PPC4000 and PPC4000 230-volt are related products that are designed to work with an external flame safeguard, such as the FireEye Burner Logix or the FireEye Burner Pro. These controls interface with the external flame safeguard in the same manner as a single-point actuator would, but allow full parallel positioning control. All accessories for the NXF4000 are also compatible with the PPC4000, and that's what we're going to go over in this presentation, except for the amplifier cards because those are not needed with the PPC4000. And there's a separate presentation available on the YouTube channel that goes into detail about how the PPC4000 interfaces with a flame safeguard. You have 3 choices for amplifier options with the NXF4000, and those are fitted with an add-on card. The first is a UV amplifier, and that allows use of any FireEye low-voltage UV scanner. We'll go over that in upcoming slides. IR amplifier and a DC amplifier, and that means direct coupled, and that allows use of certain FireEye integrated scanners. To mount the amplifier card, you're going to power down, remove the plastic cover, and then insert the amplifier card into the header that's provided on the circuit board. Replace the cover and repower. The first scanner choice is the UV1AL, and this is designed for front mounting, and it allows the scanner to obtain a clear view of the flame through a sight tube. And it comes with either a 3-foot or 6-foot cable attached, and it mounts with a 1/2-inch MPT thread. The next choice is a UV90L scanner, and this is designed for front or side mounting, and it allows the scanner to be more versatile. And it provides a field-wired terminal block, so you can use your own cable. And the third choice is the UV5. This is a more compact scanner, and it comes with a detachable cable and also can provide front or 90-degree viewing of the flame. With all of the UV flame scanners, you see the note on the bottom of the slide that they are designed for, they're non-self-checking and should only be used in an application where you're going to cycle at least once every 24 hours. Here are some photos of UV scanners. The 48PT2 infrared scanner is offered with a 1/2-inch NPT mounting in both a straight or a 90-degree version. And it has a 4-foot or 8-foot molded cable to provide the connection to the scanner. This is the scanner we recommend that you use for any application that will run for more than 24 hours continuously, as the IR technology is inherently self-checking. Here's an image of an IR scanner mounted. If you have the direct coupled amplifier, the first choice is a Phoenix scanner 85 series, and this is one of our integrated scanners, and we have a whole presentation as well on the YouTube channel about methods of flame detection that goes into some more detail about these scanners, so I won't do that right now. You can also use the Insight scanner, 95 series, as well as the Insight 2 scanner with that DC amplifier card. Here are some photos of integrated scanners and applications. So with the NXF4000, it has a best-in-class support for 4 different profiles. The most common application where you're going to use 4 profiles would be for a dual fuel burner that would have a VFD bypass option so that each of the 2 fuels can have a unique profile with a VFD bypass and without a VFD bypass for a total of 4 profiles. And each of those profiles in turn can then have up to 24 points. There are additional fuel train options, or there are different fuel train options so that any fuel can use the gas valve or oil valve outputs as needed. And there are different gas profile options to allow for the upstream valve to open with the pilot output or to simultaneously open with the downstream gas valve depending on your application. Our servos that we use with the NXF4000 is the FX series, and there's also a presentation on FX servos available on the YouTube channel. And there are 3 sizes of servos available: a 4 Newton meter or 3 foot-pound, a 20 Newton meter or 15 foot-pound, and a 50 Newton meter or 37 foot-pound. Each of these is 24 volt DC powered and operates using Modbus wiring to the NXF4000 on a secure transmission line. The NXF4000 provides up to 60 watts of power for the servos, which is enough for the typical application, but if you need more power, an external 24 volt power supply can be used as well. There's also an option for the servos to be provided with quick disconnect cables. Using the quick disconnect cables makes it easier to service a burner if you need to remove the servos quickly. Addressing the servos is done using a rotary switch, making switching out a servo very quick and easy. The NXF4000 can support up to 10 connected servos with up to 4 active on any profile. The onboard 24 volt power supply can supply up to 60 watts of power, as I mentioned, which is enough for most applications with 2 servos, as well as some applications with 3 servos depending upon the servo size. External power supplies can also be added to power any additional servos needed. The minimum requirement is that you have 2 servos or 1 servo with a VFD. The power requirements for the servos for the FX04 is 7.5 watts, the FX20 is 35 watts, and the FX50 is 38 watts. Since the FX series of servos uses Modbus to communicate with the NXF4000, they are also available for standalone use with other Modbus control systems, such as a PLC. These can be ordered at the base baud rate of 56K as well as a lower baud rate of 19.2K. Some other features of the FX series servos are that they have stepper motor control with 0.1 angular degrees of accuracy, meaning that over the 99.9 angular degrees of rotation that are available, you get 999 positions. Variable speeds of full stroke movement can be set in the control from 30 to 120 seconds. It comes with a D-type shaft for mounting to couplers. You can have clockwise or counterclockwise, anti-clockwise rotation with manual movement buttons provided under the cover to ease setup. And the servos are all NEMA 4 or IP65 rated. Here are some images of the servos in application. With the VFD, the NXF4000 can support up to 2 connected VFDs using the NXCES VFD add-on card. Each VFD is controlled from a 4 to 20 milliamp signal and must provide feedback from either the VFD's 4 to 20 milliamp output or from an external encoder. And to use the VFD, you use the add-on card as described, and it mounts in a similar manner to the amplifier add-on cards. You remove the cover, fit the NXCES VFD. There's also a presentation on interfacing a VFD with the Nexus systems available on the YouTube channel for a lot more detail on that, as well as to how to connect the encoder. We have some different interface options for the NXF4000. The first is the keypad NXD410, and I'll skip right to the note that this is no longer available for new installations, but this is going to be very common for existing installations. And this is the standard interface to allow for commissioning, monitoring, and operating the NXF4000. It's a 4x20 LCD display with dedicated keys, and it is 24 volt DC powered, and it's powered from the NXF4000. The new standard interface option is the NXD410TS 4.3 inch touchscreen, and it also allows for commissioning, monitoring, and operating the NXF4000. Operating very similarly to the old NXD410TS, you can see it also has a 4x20 virtual display and has the same buttons as the NXD410, so switching to this operator interface is going to be easy to do. It also enhances the experience a little bit with onboard help files that link to lockout codes, legends to let you know what the buttons do, as well as alternate language support for simplified Chinese. This display is also 24 volt DC powered and gets its power from the NXF4000. And now available as well, we have 7 and 12 inch touchscreens. And these touchscreens are upgrade options that allow for commissioning, monitoring, or operating the NXF4000 as well as the PPC4000. And these can be used in addition to or instead of the NXD410 or 410TS. So you no longer have to have the other touchscreen as well. This can be your only touchscreen. Additional features from these displays are a Modbus TCP server, VNC remote monitoring capability, and support for a custom language editor. These displays are 24 volt DC powered as well, and they can get their power from the NXF4000 and are intended to be panel mounted. So the components you need for a minimum system, to get a working NXF4000 system, the first thing you're going to need is a control, and that can be either the NXF4000 or the NXF4000 230 volt. You're going to need a terminal block kit. You're going to need an interface, and that can be the NXD410 or the NXD410TS or the 7 or 12 inch touchscreen. You're going to need one amplifier, either the IR, UV, or DC amplifier. And then you're going to need servos, which can either be any two of the FX series or any one of the FX series with one VFD connected. And you're also, of course, going to need an actual scanner and cabling and things like that as well. But this is the minimum requirements to get a working system with the NXF4000. The NXF4000 has flexible line voltage inputs, has 15 available, and these can each be user assigned for a variety of options. And there's also a presentation on YouTube where we go into detail about all of the inputs you can connect, all the ways you can use these digital inputs, such as making first out enunciation, etc. Dedicated inputs can be used for special functions such as valve proving, airflow switch proving, fuel valve end switch, proof of closure, and more. Additionally, the inputs can be used to create a first out enunciator by tapping into each connection on the limit string. Any loss of safety limit will then create a unique lockout indicating that the input is not on before the control issues the general safety limit lockout. Inputs can also be read over Modbus for further processing or enunciation if you're using a Modbus connection. There are 5 4 to 20 milliamp analog inputs used for connecting the field sensors. The most common uses are for connecting the control sensor, which is going to be your steam pressure or hot water temperature sensor for controlling the process, as well as for connecting the standby water sensor on a steam boiler. When configuring a sensor, the list of available functions and sensor ranges are presented on the screen for you. A remote 4 to 20 milliamp modulation signal can also be used directly if the control is set for track modulation. So here are the available sensor ranges that can be used. We have 5 different steam pressure ranges, 2 temperature ranges, as well as an outside ambient temperature sensor. There are 3 user assignable line voltage outputs available, and these can be set with different on and off assignments, so they can be used for sending status to a BMS or a PLC system. They can also be used to control other accessories such as pumps or valves. Additionally, connected analog inputs can be monitored for high values, and alarms can then be directed to the user assignable outputs. So you can have a analog input monitoring a temperature, and when you reach a high temperature threshold, you can assign one of these line voltage outputs to turn on when you reach that threshold. There are also user assignable 4 to 20 milliamp outputs, and there is one user assignable 4 to 20 milliamp output by default, And these can be set for a variety of different uses, such as to retransmit an analog output, or to indicate the modulation rate or a servo position. And if an NXD or an NXCES VFD card is fitted, that's the VFD add-on card, any unused analog outputs from there can also be used in this manner as well. So if you only have one VFD, your second VFD channel that's unused, you can use the analog output to assign a temperature retransmit, a servo position, or whatever you would need to use it for. We also have thermal shock or warming available as an additional feature. And this is typically used with a steam boiler, and this involves checking the temperature upon startup. Depending upon the setup options chosen, modulation will be restricted by the temperature or will gradually increase in steps as the temperature increases. To use this feature, a sensor is chosen and the desired algorithm and set points are entered. This feature can also be used with a steam sensor, although this method is not recommended. We typically recommend use the temperature sensor for this. And this is how that would work. So if the first way you can use that is via temperature hold, and if you use this method, a set point is selected, and when you reach that set point, modulation will begin. Any temperature below that set point, the burner will modulate only at the selected firing rate. And there is a whole video on temperature sensors and steam boilers available on YouTube as well that goes into not only this, but hot standby, which we'll go over on the next couple slides. The next method is via segmentation. And in this method, a set point is selected that will allow modulation to begin, which is the start set point. And between that set point and the stop set point, it's divided into 16 steps of modulation. And you can see it'll step up gradually. And you can set time limits for each step. So if your time limit is exceeded, it'll move to the next step. Or if the temperature threshold is reached first, it will move to the next step. Hot standby is available, and that's a function of a lead lag scheme. The concept with hot standby is that the boiler is kept hot while it is in standby to the system. This is so that the boiler is kept ready to produce steam quickly when it is needed again. Hot standby can be activated if there's a standby water temperature sensor connected. That's the first requirement. There also needs to be a control scheme in place, which is the second requirement, and that can be peer-to-peer sequencing, which we'll go over in the next couple slides, or track modulation from a BMS. When track modulation is used, a digital input must be assigned to enable the control. Hot standby can then occur if a lag boiler in a peer-to-peer system is idle, or if the digital input for track modulation is not made. So that means when the BMS system does not need that boiler to run, you can activate hot standby so that it can turn on. When standby mode is active, a unit will operate to maintain the desired water set point instead of the usual pressure set point. Any other functions such as thermal shock will still apply before modulation will occur. Up to 6 NXF4000s, and this can also include PPC4000 controls if your system had both. They can be connected together with a dedicated Modbus connection for peer-to-peer sequencing. One control is selected to be the lead control by using either the interface, the keypad, or by using a digital input. The lead control will determine when to bring lag controls online based upon the total number of slaves as well as the on and off points entered. Each on and off point also has an associated delay timer to ensure that the on or off condition lasts for a minimum amount of time. Hot standby can also be enabled for any lag boiler connected by this sequencing so that a minimum water temperature is maintained. So with peer-to-peer sequencing, you have a lead boiler and it will determine if you need to bring on additional lag boilers to maintain the load. The NXF4000 contains a real-time clock that is used to record fault history and implement the setback schedule. To operate properly, the real-time clock should be checked and set correctly periodically. The NXF4000 maintains the last 10 lockouts in the non-volatile fault history, and this can be accessed at any time, and the interface will automatically show the fault history page or a link to the fault history whenever a lockout occurs. The setback function allows choosing a setback set point with a time to begin as well as end the setback period. There's an action for each day, whether to use the setback all day, not use the setback at all, or to follow the time of day schedule as set. Additionally, if setback is used, digital inputs can be programmed to override the setback or to implement the setback with priority. When being controlled using the internal PID control and stat, the firing rate will always be reduced to low fire before entering post-purge and ending the burner cycle. This is known as assured low fire cutoff. If a limit input is the cause of the shutdown, the control will shut down the burner immediately regardless of the firing rate, because that is from an external source. The FireEye NXCES02 zirconium dioxide probe is designed for use with the NXF4000 and provides continuous oxygen concentration readings, allowing the NXF4000 to trim the air or fuel servo to obtain combustion efficiency. This is the oxygen trim system. The NXCES02 also incorporates a Type K thermocouple, which can measure the flue temperature up to 800 degrees Fahrenheit. This is available in 2 insertion depths, either 8.5 or 16 inch for the stack, as well as mounting accessories. With the NXCES02, the operating temperature range is 0 to 60 or 32 to 140, and that's the ambient temperature around the probe. An optional ambient air temperature sensor can also be added to allow for efficiency calculations to be made, and that would be connected directly to the NXF4000. The NXCES02 probe connects to the NXF4000 using a Modbus connection. The required connections are 24 volts DC power, which is sourced from the NXF4000, as well as the Modbus cable connection. The same cabling used for the servos is used to connect the NXCES02 to the NXF4000. Since the NXCES02 uses Modbus to communicate with the NXF4000, it is also available for standalone use with other Modbus control systems. With the NXCES02, the probe assembly is easily removed for service or replacement, and this would eliminate the need to remove the probe assembly from the stack itself. If the ambient temperature range needs to be exceeded, we have another option, and that's the FXCES02 with the FX02 Trim-1 control board. And this is a zirconia oxide probe that is an alternative for industrial applications where the operating temperature would be in excess of 185 degrees Fahrenheit. This also incorporates a Type K thermocouple to measure flue temperature up to the maximum temperature rating of 1,112 degrees Fahrenheit. The higher range is due to the remote mounting of the electronics. The electronics in the NXCES02 probe are mounted to the probe, whereas this electronics in this case is mounted in the FX02 trim, which is going to be mounted remotely. We have 3 insertion depths available here, 8.5 inch, 16 inch, and there's a longer 31.4 inch as well. The operating temperature range for the FX02 trim interface, and that's the electronics themselves, is the same as the NXCES02 at 0 to 60 or is 32 to 140. But since it's remote mounted, the ambient temperature at the stack is higher. An optional ambient air temperature sensor can also be added, just as with the other O2 trim option, to allow for efficiency calculations to be made. The FXCES02 probe connects to the FX02 Trim-1 interface using a CAN bus connection. Special cable must be used for this connection, and it'll have a limit of 33 feet. In turn, then the FX02 Trim connects to the NXF4000 using a Modbus connection, same as the NXCES02. The required connections are 24 volt DC power, which comes from the NXF4000 as well as Modbus. If oxygen trim is enabled, there are 2 control modes, monitor and control. If monitor is chosen, the O2 level will be monitored and displayed on the top level of the interface. O2 limits and flue temperature limits are still monitored, and alarms can still be issued based on those limits. If control is chosen, the system will actually trim the O2 level automatically using the trim channel chosen, and that would be air or fuel. Trim limits and PID gains are set to tune trim control. If an O2 limit is reached, the choice can be made to either issue a warning and disable trim or to lock out. The NXF4000 offers a Modbus RTU interface as standard for communication to a BMS or PLC. When the NXTSD507 HD or 512 HD, the 7 and 12 inch touchscreens are optioned. These use that Modbus connection, and so in turn a Modbus TCP/IP server is offered as a replacement out of the touchscreens. All operating data can be monitored using the Modbus connection. In addition, commands can be sent to activate the local interface keys such as burner on-off, auto manual, low fire hold, and manual firing rate. Set points can also be written over the Modbus interface. The NXF4000 has a built-in SD card reader that can be used to back up profiles, parameters, or both. Each unit also ships with an SD card as standard. This makes it easy to back up site configurations as well as to migrate settings from one unit to another. Software is available so that any backup file can be viewed on a PC using Microsoft Excel or similar program. You search for SD card file reader 2.3 on the FireEye website if you want to get this program. And this program converts the backup file created by the NXF4000 into an XLSX, which is an Excel file that can be saved for reference. All the setup and commissioning data is presented using different tabs. When using an SD card, it is recommended that it is 32 gigabytes or less, that's what we use, and formatted to the FAT32 file system. It is also recommended that you use the format option with a new SD card, and then the NXF4000 can format it for you in the proper format. Here is what the Excel backup file would look like. You can see it separates everything out with tabs at the bottom, sensors and set points, servos, digital inputs, etc. And then all the information is then available for viewing. So in conclusion, the NXF4000 is a full-featured parallel positioning system that will rival any other in the same class. It also offers many unique features such as support for 4 profiles and peer-to-peer sequencing that most competing parallel positioning systems don't support. For applications where the NXF4000 does not fit for technical reasons, we have the related PPC4000 product, and that may be able to be used with an external flame safeguard. The Burner Logix and Burner Pro flame safeguards offer support for many additional configurations such as flame rod, UV self-check, that the NXF4000 may not support. The PPC4000 can also be retrofit in applications where a flame safeguard already exists and needs to be retained, and this is possible even if it is not a FireEye branded flame safeguard. All the same accessories work with either the PPC4000 or NXF4000, and peer-to-peer sequencing will even work between NXF4000 and PPC4000 units mixed together. So lastly, the NXF4000 offers a simple menu structure as well as an intuitive interface, and this means that it will be one of the easiest controls to configure, commission, and maintain. And when we get back into the training, I hope you guys can see just how easy it is to commission. So I did have one question, and then I'll take any other questions if you guys want to put them in the chat. What is the 60-3005 terminal block kit? And this is a recent development, and you should be getting information from your RSMs about this soon. The terminal blocks on the NXF4000 and PPC4000 up until now have been shipped with the control, but they're becoming a separate part. So the control's price will be decreased accordingly, and the terminal blocks will be available separately. So you'll now order a control, and you'll order a terminal block kit separately. And that terminal block kit is the 60-3005. And the VFD card will now come with the terminal block for the VFDs separately. So there was a small change, and you should be getting information from your RSMs about that. All right, so again, if you have any questions, please ask them in the chat. I'll give you a little bit of time for that. And if not, thanks for joining, and check out the YouTube channel. I'll send out a link to this video in a couple of hours. We have all the other videos on digital inputs, connecting the VFD, steam and temperature transmitters, and many others. So thanks again, guys. Have a good day. Okay, I got a question. Do you have or can you provide a wire-to-wire cross-reference diagram from the Honeywell control links to the PPC4000? And the answer is we don't have a wire-to-wire cross-reference diagram, but what we do have is something called the PPC4000 Wiring Application Guide. If you look up that term on the FireEye website, PPC4000 Wiring Application Guide, or go to the PPC4000 section and click on Service Guide, you'll find the PPC4000 Wiring Application Guide, and it has 48 different wiring diagrams, and some of them are how to wire a PPC4000 to a 7800. So I think that will satisfy the same requirement. So we do have that available. Another question, how the user would develop graphics pages in the HMI. Right now the HMI has a static graphic, but we are hoping to incorporate in a firmware revision to that the ability to change the graphic in the near future.